Good afternoon, everyone. I am Oleg Pursky with Kyiv National University of Trade and Economics and head of Department of Computer Science and Information Systems. Dear colleague, let me present to your attention the result of our research on the topic computational method for risk assessment of regional socioeconomic development. Firstly, about the problematic shortly. One of the main problems in the risk analysis of socioeconomic system is the construction of adequate method. This is due to the multidimensionality of socioeconomic system, the stochasticity of their behavior, as well as the complex interaction between the elements of the system. The main problem that arises in the socioeconomic studies is a real conclusion. In statistical calculation, the importance of socioeconomic indicators for the socioeconomic system is not taken into account. In this case, only the weighted average of such indicator is considered. This problem is solved by expert evaluation. Knowledge and experience of expert make it possible to run the indicator in terms of their importance for ensuring the effectiveness of the socioeconomic system. At the same time, however, expert evaluation fails to establish the correlation between indicators. This task is successfully managed by factor analysis. It is an expert statistical option that is most suitable. Due to the above said, the purpose of our study is to develop a reliable computational method for risk assessment of regional socioeconomic development on the basis of the joint use of method of factor analysis and expert evaluation. This study poses and solves the problem of formalization of risk assessment for regional socioeconomic development with the key region districts as an example. This slide presented the development model for assessment of integral risk indicator of regional socioeconomic development. We can see two main parts of model connected with two different calculation mechanisms. First is factor analysis, and second is expert evaluation. In this model, the weight of factors that take into account both the weight of the factor determined by expert and the weight of the factor determined statistically can be obtained as the weighted average of these two evaluations according to Formula 1. This complex indicator of socioeconomic development for a region is calculated as the sum of factors with the corresponding weighted average weight coefficient according to Formula 2. Taking into account the proposed complex indicators of socioeconomic development, the value of integral risk indicator in the region can be calculated using the Formula 3. As this slide presented the general scheme of development computational method for risk assessment of regional socioeconomic development. This method makes it possible to develop a procedure for automated data precision of socioeconomic research and includes the following stage. First stage, the entering of values of indicators of socioeconomic development and expert evaluation in the form of the matrix of indicators and the matrix of expert evaluation of indicators, followed by its normalization to a single scale of measurement. Second stage, the calculation of the pairwise correlation matrix and determination of the eigenvalues and eigenvectors. Third stage, obtain a matrix of factors by multiplying the normalized matrix of indicators and the matrix of eigenvectors and normalization of factors and calculation of their variance. Fourth stage, determine the number of factors included in the integral risk indicator on the basis of eigenvalues of the matrix of pairwise correlation of indicators in the given boundary variance of dispatching of normalized indicators. 5 stage. Determine the relative contribution of each of the factors in the description of the total dispersion of all indicators as a ratio of the eigenvariance of the factors to the total dispersion. 6th stage. The determination of the expert's competence in calculation of the Kendall's coefficient of concordance for evaluation of the consistency of their conclusions. 7th stage. The determination of weighting coefficient of factors included in the integrated indicator. 8th stage. The calculation of integral risk indicators of regional socioeconomic development and the visualization of the result of data procedure. Technique to mark this clear implementation of the method of calculating integral risk indicator of regional socioeconomic development is carried out in the C# programming language. We consider the process of risk assessment for regional socioeconomic development in accordance with the developed computational method for integral risk indicator on the example of the Kyiv regional districts. At this slide, you can see indicators and name of districts that used in calculations. In table 1, you can see presented in single scale of measurement and normalized values of socioeconomic indicators of districts used in calculations. On the basis of the normalized matrix of socioeconomic indicators, we calculate the pairwise correlation matrix of indicators. For the pairwise correlation matrix of indicators, we determine eigenvalues and eigenvectors that presented in table 2. The matrix of factors is obtained by multiplying the normalized matrix of socioeconomic indicators into the matrix of the eigenvectors of the pairwise correlation matrix. The obtained factors are normalized. The normalized factor matrix is used to calculate the matrix of correlations between factors and indicators of socioeconomic development that is required for the interpretation of factors. Table 3 shows the structure of factors. The coefficient of correlation between indicators and factors in which they are included, statistical and expert weight coefficient and weighted average weight coefficient of factors. The third factor included the first 4 indicators. The number of cars per 1,000 people, service rendered per unit of population, natural increase reduction of the population, and the level of registered unemployment. The second factor included the 11th indicator, emission of population. The third factor entered the 7th indicator, the ratio of the built housing to the population. In table 4, present the value of integral risk indicator of socioeconomic development calculated for key regional districts. On the slide, you can see diagram of ranking of key regional districts in terms of their risk assessment of socioeconomic development. Conclusions. The time result demonstrate that the presented computational method solves the problem of formalization of risk assessment for the socioeconomic development and can be used to analyze and predict the socioeconomic situation in the region. In the framework of the presented method, by changing the values of socioeconomic indicator, it is possible to analyze and model the socioeconomic situation in the region, which undoubtedly provide management with valuable information on possible risk and direction of effective strategies for socioeconomic development. The management receives not only adequate assessment of the risk level of socioeconomic development of the region, but also opportunity to determine the immediate causes and consequences that shape the current and future socioeconomic situation in the region. The result of modeling the process of assessment of level of socioeconomic development of key region show that the main advantage of the method of determining the integrated risk indicator are the possibility of studying correlation between socioeconomic indicator, between indicators and factors, interpretation of factors, determine negative and positive characteristics of socioeconomic situation in context of research objects. Thank you for your attention.